Hi all, welcome to this breakout session on implementing cafe-like branches with Zero Trust SD-WAN. My name is Amit Naik. I'm a Director of Product Marketing here at Zscaler, and I have a very special guest here with me, Nuno Diogo, a Principal Product Manager for Zero Trust SD-WAN. Nuno, you want to say a quick hello?
Hi everyone, as Amit mentioned, my name is Nuno Diogo. I'm one of the product managers focusing on Zero Trust SD-WAN here at Zscaler. It's nice to be with you today.
You've heard from our CEO and product leaders about Zero Trust segmentation for branch and cloud, the industry's only solution that enables you to eliminate lateral threat movement without the cost and complexity of putting firewalls everywhere. And one of the ideas you may have heard about in the session earlier is cafe-like branches. So let's double click into that and understand why you should be thinking about this for your network architecture and how this enables you to not only address security issues, but also significantly reduce costs for your infrastructure. So without further ado, let's jump in. And I'm going to ask a question to my colleague. So Nuno, what does a cafe-like branch mean to you?
Yeah, so a cafe-like branch or Starbucks model or routing island, they're all terms that I've heard executives use to try and communicate a concept where a branch can and should be as simple as Starbucks, right? Meaning that for the end user, it's better performance. They connect their laptop. They connect directly to the resources on the internet that they need to have access to. It is easier to manage because you're not necessarily creating this overly complex infrastructure at every single branch, right? It's certainly the real, to me at least, the crux of it is really the security of it, right? And the fact that these are supposed to be untethered locations, just like a Starbucks, that has no inherent connectivity to the network, right? And so this kind of goes hand in hand with another term that I hear quite often, which is getting the users off the network, right? In the context of security, so that when that user laptop becomes compromised, that blast radius and therefore the risk to the business is severely mitigated. So it's all of that encapsulated in this cafe-style branch office where it's more simple, it's better performant, and critically, it's much more secure because it's not connected to that traditional corporate WAN as we've been accustomed to for the past 20, 30 years.
One of the other big challenges we've been dealing with as an industry at large is ransomware. And ransomware kind of operates in a few ways, right? So ransomware tries to find a point of entry in your organization. It could be an employee sitting somewhere that clicks on a link, or it could be an IoT device, a camera that's sitting in the branch office that has a zero-day vulnerability that you don't even know about, but it's there, it's on your network, and once that camera gets infected, it now has the ability to scan your entire network and find other assets, find crown jewel applications, and go move laterally and infect them as well. And this is fundamentally one of the reasons why ransomware attacks happen so quickly, and they're so destructive to an organization.
And the key term that you said right there is it's on your network, right? You have that, it's on your network. And because it's on your network, now it can propagate laterally. It can discover what's out there. It can traverse these routable paths across multiple sites, reach your crown jewel applications in your data center or other environments. Absolutely.
So it sounds like something everybody should be doing. So walk us through, how does it actually work in the different scenarios that we see here? For small branches, medium branches, campuses, and factories, what does it actually involve?
So, of course, deploying the solution that allows systems and systems that are unmanaged systems is really kind of the critical aspect of it, right? Because managed systems, we at Zscaler, we've had a client connector, a software agent available to our laptops, phones, iPads, etc. for many years, right? But it still kind of had a gap on unmanaged devices. Because to your point, those 0 days on IoT devices, how do we ensure that those systems, those printers, IP cameras, door badge readers, all that other stuff that resides within a location, how do we bring that into the Zero Trust fold? How do we ensure that they only connect to things that they should be connecting to based on policy, and not that they don't have access to a full-blown network through routed paths, across the board there. So it's really about implementing that Zero Trust fabric so that things can communicate, because there's a policy that says that can communicate to certain things, right? Print server can communicate to print device can communicate with the print server and perhaps a couple other systems for monitoring, etc., but nothing else. As opposed to the current state, which is I can communicate to anything that I have a routable path to, right? And as we understand your traditional WAN with dynamic routing protocols, BGP, OSPF, etc., all sharing all these route tables across all the sites, you have this basically this network overlay that allows things to communicate to just about every single site, right? Unless you go on top and then put firewalls and IPSs and everything else after the fact, trying to prevent bad things from happening. So the way to think about it is really to pivot that upside down and try to start where you want to end up, right? We all in our industry believe in a least privileged access model, but we still start on the complete opposite end of the spectrum where everything can have access to anything else unless we actively prevent it with a firewall, ACLs, etc. The concept here is we start on the other end. We start where we want to be. There is no connectivity to anything from anything unless there's a policy that allows it to go through via the Zero Trust Exchange, via the Zero Trust.
You make a really good point there about, we've started at the opposite end and that's not by accident, right? So the current generation of IP networking was designed at a time when, things could not talk to each other. And we had to make it easier for devices and systems in an organization to talk to each other. And we got really good at that to the point where now everything has the ability to reach everything. And coming into that and overlaying and firewalls and putting in gates and walls and checkpoints all throughout that, it's messy, it's complex, it's expensive, and it contributes to a lot of sleepless nights for network admins. And rather than starting there, we're starting at the opposite end of the spectrum where, starting with nothing's connected. And then when you need connectivity between applications, you need connectivity, let's say from an IoT camera to the internet to talk to a controller. You allow that, but then at the same time, you can block connections to malicious CNC sites, for example, right?
Absolutely. And I think again, it's a function of the times, right? Back then, the focus was connectivity. Can we connect, right? And we went from frame relay to MPLS, and everybody was amazed by MPLS because, again, I pick up my VoIP phone, I dial an extension, and it goes straight to the other branch over that MPLS cloud magically, right? So the focus was always connectivity. Today, the focus is secure connectivity, and that is a big, big difference, right? So yeah, fully agreed. It's a change of times, and the times and the expectations and the requirements have changed, but up until now, the infrastructure has not changed to keep up with that, right? We were still building things of let's provide connectivity first and foremost, and let's try to overlay security on top and hope for the best. And ultimately, it's complex, it's messy, everything that you said, and it hasn't proven to be, very effective, right? If we were honest with ourselves.
And then the other question I usually get is like, hey, this is great. I can segment down to the branch level. What do I do within the branches? And this is where device segmentation is a huge help. Watch the device segmentation breakout as well when you're done with this. That'll get into details about how we do that. But essentially, to give you the nutshell version, is we can segment every device in the campus, in the factory, down into a segment of one. Right? And if you want to learn more, watch the breakout. So how can somebody get started with this, right? A lot of people have SD-WANs already deployed and branch infrastructure already deployed. Can you walk us through the options available to our customers?
Certainly. And there's really just two, right? What we call non-gateway or single NARM mode, and then gateway or inline mode, right? And most organizations start dipping their toe in the zero trust water here with the architecture on the left, meaning that they don't want to disturb the existing site, right? Usually, the world is gray, right? It's not greenfield 9 times out of 10. And so they want to kind of start implementing this native zero trust architecture, but they have to be very careful. They don't want to cause service disruptions, etc. So with the non-gateway mode, we simply install one or a pair of branch connectors and HA, of course, on the LAN side of that environment. And then, like I said, it's a 1R mode. So you install it, you set it up, it connects to the cloud, it's fully instantiated, and so on and so forth. So it's up and running, but no traffic is going through it yet. And now the customer, based on their own, risk envelope and criteria, they can select either a single application, a single server via PBR to be redirected to the new brokered zero trust path, and everything else stays on the traditional routed path that's been in place for a while, right? Or they can grab an entire VLAN or even the entire site, right? Certainly I've seen customers say, you know what, I just want to put quad zeros and send everything to the branch connectors for inspection and encapsulation, and then off it goes. So the customer has a lot of options there on how granular they want to be and how careful they want to be at shifting the traffic over time. So there's a lot of benefit to that type of architecture, of course. The obvious negative of that is that it's additive to a branch location, right? And most folks don't want to add more stuff to the branch. Zscaler is aligned to that. approach. We believe in a thick cloud, thin branch type of architecture. So the natural evolution of this architecture is to then move those branch connectors left and up, so that they not only provide the Zero Trust overlay capabilities that we were talking about via the Zero Trust Exchange, but they are also now in charge of managing the underlay per se, and therefore fully replacing the existing edge device, whatever that may be, a traditional SD-WAN device, a firewall, whatever happens to be there, right? And so in that mode on the right there, the gateway inline mode, the branch connector is terminating the WAN circuits directly, TIA circuits, broadband circuits, whatever that happens to be. It is terminating the LAN circuits as well. So the LAN site switches connect directly to the LAN interfaces of the branch connector. And we have all of the capabilities that are expected from this type of enterprise edge device. And that's something that is fairly recent here with gateway mode. And I know we'll cover that in a future slide as well.
So these are great options for our customers to start their journey on this path, depending on where they are, right? If they're looking at greenfield deployments, a whole new retail network, a new factory, they could start at the right, or if they already have an existing environment that they want to get into, they could start at the left, which is great. And I know we have a couple of options for them to get started from an appliance perspective. So the Zscaler Edge comes in a few different form factors. So walk us through what these are.
Sure. So I'll start on the right, which is the component that's been around for the longest, over 2 years now, and that's the virtual branch connector. We still leverage that pretty heavily at large campuses, in particular data centers. Okay. And so with the virtual branch connector, you get to leverage the existing compute capabilities that are available at that location. You scale those out. And there's different methodologies of doing that, depending on the use case. If it's a very focused M&A use case, hey, I just want this to handle my M&A traffic to the acquired company, for example, then you might be able to just get by with an active passive pair. If it encompassing broader use cases, which we're seeing more and more, we see customers starting to build out active clusters, N+1, behind a third-party load balancer like an F5 big IP or NetScaler or something along those lines. So different ways of kind of going about it. That's with the virtual component, pretty flexible. And then on the hardware front, which we introduced last year, we started on the smaller end of the branch spectrum there, from a very small 200 megabit throughput site to a medium side size site with 1 gigabit of throughput. So these are your traditional SD-WAN appliances, small form factor with a bunch of ports in the back, and they are the ones that provide that underlay management and the overlay, the Zero Trust overlay capability as well.
So a lot of options, and we've got a few new ones coming up, which we'll talk about in a minute. But before we go into that, let's walk us a little bit through the gateway mode capabilities that we launched this year, right? What does it mean? What can we do, and what does it do for our customers?
So I think one of the first things that we focused on with the appliance is that zero touch provisioning process, right? Which is key as you're kind of rolling this out to hundreds and hundreds of locations, right? So again, we take the good parts of all of the different technologies that have come before. So one thing that SD-WAN brought to market, a little bit over a decade ago now, is that easy button, that zero touch provisioning concept, where we can drop ship an appliance directly to the location where it needs to be utilized, and a non-technical person can grab it, connect the power cable, connect a couple of Ethernet cables, and the appliance, the branch connect in this case, automatically phones home, registers with its serial number, authenticates with the certificate that's burned into its TPM chip, and connects to the correct tenant, pulls its configuration, and finishes instantiating itself. And so that was a big focus of the zero-touch provisioning process that is specific to our physical appliances today, all right? In combination with the gateway mode, like I alluded to on the previous slide, all of the required capabilities of an edge device, like providing DHCP server capabilities, so that nodes connecting to that LAN can automatically get their IP configuration. DNS Gateway, right? Without DHCP, without DNS, that branch office would not be functioning, of course. Things like inter-VLAN segmentation is terminating 802.1q trunks, so that you can do that firewall on a stick traditional type of architecture. Of course, we've advanced that with the new capability that is we're highlighting on the other breakout. But we're basically started where everybody has been for the past 20 years, right? That firewall on a stick mode, where you can carve out different VLANs, and then you can filter out what can communicate between VLANs. That's all part of the structure there. Certainly terminating dual WAN circuits. We're starting with just two WAN circuits. There's no inherent limitations, just in guardrails that we put here initially. We will support more than two WAN connections for sure. And then doing that traditional ISP or path monitoring, looking for latency and packet loss and jitter, and then deciding which path is the best path for that session to traverse, and even allowing the customer to then define, hey, what is that path that I want this particular application to take, right? High availability from a link redundancy, active standby, all of that is part of it. And then the critical part of it is really that traffic flooding, sending those sessions into the Zero Trust Exchange. I always say the same thing. The Zero Trust Exchange is the star of the show, right? That's where we actually apply policy. That's where we do the inspection of the traffic. The appliance itself is a light appliance, purposefully so. Okay, we do the basics on that. We identify what traffic it is, and we identify where it needs to be sent to for policy enforcement. So those are the crux of the gateway mode capabilities of the branch connector to enable that Zero Trust branch.
This is a great overview. So let's take a deeper look at some of the two biggest capabilities people think about when they think about connecting the branches, right? Like, how do I make sure that my branch stays up, and how do I make sure my apps are performant, right? And we've got some cool capabilities there to support that. And the first one's around ensuring high availability on the WAN side.
Yeah, so high availability, there's several layers. We're going to touch on three of them, I believe, here today. So, like I talked about, most environments that have any sort of SLA attached, most branches that have some sort of SLA attached to must have more than one WAN connection out, right? That last mile. It can't be just, dependent on a single connection out of that. So the standard configuration is to have two WANs from two different providers connected to the branch connector, and we obviously, by default, we will load balance both WAN connections. So both WAN connections will be fully utilized. It is a per session load balancing algorithm, and but certainly the customer has the ability to configure and make it a second link as standby instead of active in case it's a metered connection, like again a 5G dongle. Or I'm seeing Starlink quite a bit these days, right? Those are metered connections, so they may not want to use it all the time. They may want to use it, only when they have to. But by default, the branch connector will load balance the two WANs and, of course, failover, okay? So that's high availability from a last mile or WAN connectivity standpoint, okay? That's the underlay, right? Where can I push packets through, right? Then we have the quote-unquote overlay, which is that Zero Trust fabric. And so what we're depicting here are two sides of our fabric. We have the SSE stack, the Secure Services Edge stack, also known as ZIA, right? That's all the stuff that goes out to the internet. This is where we do SSL inspection at scale, apply cloud firewall policies, IPS, sandboxing, DLP, like the whole nine, right? And so in that type of environment, it is a traditional primary and secondary tunnel. We only use the primary, secondary is on standby, and we create those on a per WAN link basis, right? So in an appliance that has two WAN links, you would actually have 4 tunnels to the 2 closest Zscaler data centers. That is all automatically done. Customer doesn't even have to think about it. It's plug and play. The appliance geolocates itself, figures out which ones are the 2 closest Zscaler data centers, and establishes these primary and secondary tunnels per WAN interface. On the Zero Trust Fabric, the ZPA side of the house is slightly different. We actually establish 4 connections per WAN interface for a total of 8, and all 4 channels are utilized concurrently. Okay, so a little bit of a different architecture there, but the point remains that we provide both underlay resiliency, last mile, right? ISP1, ISP2, and then on top of that, we provide resiliency for the overlay, both on the number of tunnels and connections that we establish, as well as the different Zscaler data centers that are geographically close to that particular branch. And again, this is fully automated. Customer, generally speaking, does not have to worry about configuring any of this. It just happens. And then the last part of high availability here is on the LAN side, right? So if I have printers, if I have users, if I have anything connected on my LAN side, I have to have resiliency. If I have an SLA for that site, I have to have resiliency from an outbound perspective as well, right? So you can certainly deploy, and we recommend deploying branch connectors in an HA fashion. We follow a very traditional network HA approach of an active standby virtual IP-based solution. Anybody that's listening to this that's ever configured HSRP on a pair of Cisco routers knows what I'm referring to. So you can configure a VIP, a virtual IP per LAN, per VLAN, normal constructs, so that when you set that VIP as the default gateway for a particular segment, VLAN 10, VLAN 20, et cetera, there's survivability there, right? If something happens to the to branch connector A on the left, or to the uplink, we automatically track the uplink. So if the uplink also goes dead, then that VIP automatically floats to the secondary branch connector so that the communication and the service availability is uninterrupted from a user or device perspective on the LAN side. On this side here, what we're talking about is application-aware path selection. So going back to having multiple WANs, if the customer set both WANs as active, right, which is again the default setting, by default we will load balance. But the customer can certainly override that behavior on a per application basis, and then create a policy, which again, typical example here would be, hey, if it's Zoom, if it's WebEx, ensure that it goes over the uplink that has the least latency, packet loss, and jitter. And again, this is automatically tracked by the appliance, no configuration needed. The policy itself would have to be configured because it's based on the customer's desired outcomes here and what type of application they're interested in protecting and ensuring that it goes over the best performing path. But none of the monitoring needs to be configured automatically. We will start monitoring at different layers with the performance of these uplinks and decide which path the application should take. So this is, again, that traditional path selection or app-aware path selection. Another capability here that I'd like to usually highlight is this DNS Gateway capability. And so I'll summarize it as such. It's basically a DNS conditional forwarding system that we built. And this allows customers to start massaging or treating DNS in a specific way and making decisions based on what domain namespace is being requested. So a very usual or a very typical configuration is, hey, if the branch connector receives a DNS query for ESPN.com, Yahoo.com, something out on the open internet, then why send that to an internal DNS server? Why not just send that directly out to a public DNS resolver, Quad 8, Quad 1s, doesn't matter, and still maintain full visibility, still maintain full security, because that DNS query is actually going to be sent via ZIA, our SSD inspection stack, that will ensure that there's no malicious DNS tunneling trying to exfiltrate data or establish some sort of control channel there. Okay, so we're inspecting that DNS traffic in our cloud, right, where it should be inspected. But the branch connector is breaking that out specifically and say, okay, go this way, right? But now if the DNS query is something internal, right, acme.internal, whatever it is, we can create a policy that says, okay, these particular DNS queries go to our enterprise DNS resolver, info blocks, Active Directory integrated DNS, whatever the customer happens to have for resolution. What this capability brings to the table that's pretty interesting for organizations that do a lot of M&A is being able to break out these particular DNS queries and then say, oh, you're trying to access a resource that's on a newly acquired organization, or vice versa, right? So for those particular resources, again, acme.internal versus acme.local or whatever the scenario is, send those DNS queries to a different DNS resolver. So again, basically a conditional DNS forwarder that we've built in, or a gateway that we built into the branch connector that provides that security, that visibility, and importantly, that connectivity.
You know, M&A is especially a great use case for Zero Trust SD-WAN, right? Because the traditional way to do M&A integration is set up some kind of NAT gateway between the two networks, or you know, even go to the pain of renumbering everything, right? Which is just challenging and difficult and painful and never ending. And you lose a lot of time, you lose a lot of productivity. So with this architecture and using some of these conditional DNS resolution requests that you've talked about, right? You can actually integrate two sites and have new users connecting to corporate applications on day one.
Exactly. Absolutely correct. And reasons, again, why M&A was such a good use case, even for the earlier days of our journey here and on the Zero Trust networking. It's always been a great fit because there is, generally speaking, there is no inherent connectivity still. Folks don't want to establish that connectivity, right? These are now board level directives that, yes, we have to run our M&A playbook and integrate systems and achieve those synergies, everything that we know about M&As, but do that without connecting networks, right? Which is an interesting challenge, right? So now, I mean, I've heard folks doing like transitory things and funky things just to get packets to go across. And so this is a very clean, very secure architecture that focuses on connecting applications to applications, like Active Directory to Active Directory or ERP to ERP, without having to connect at layer 3 first and foremost, which is where all the challenge and the risk comes into.
That's great. Yeah, and these are some of the great capabilities we brought to the market this year, but let's jump into some newer capabilities that are coming soon. So one requirement I hear a lot from customers is that, hey, this is great, but I still have my legacy applications that are on premises, that may be sitting in a colo, that may be in their own data center. I still need to support them, right? And some of those applications need things like source IP visibility. A great example is VoIP. So we're bringing some new capabilities to Zero Trust SD-WAN to enable this transition from the old world to the new world. So talk to us a little bit about how this works.
Yeah, so I smile a little bit because it's certainly a challenge, right? Those legacy protocols like VoIP, like TACX Plus, and other things that have been around forever now. And again, to your point, expect that source IP visibility and reachability are still hanging around, and it can actually become, it can prevent an organization to move forward and execute on their zero trust, goal, right? Because the reality, and this is, reality, right? And I smile because I remember a customer, and I will quote him saying, hey, we want zero trust, not zero work, right? Meaning that things still need to function, right? And that's the reality. It would be great if it was greenfield and we could ensure that every protocol was a cloud-friendly protocol, a zero trust-friendly protocol. But that's not the reality, right, that we have to deal with. So what are we bringing to market? We're bringing what we're terming a third-party tunnel, a pretty standard term out there. And it's basically the capability of the branch connector to initiate an outbound only IPsec tunnel, meaning that we are only the initiator. We will not terminate or receive any IPsec tunnels because that would expose us from an internet attack surface perspective, and that would put us in the same challenges as all the other architectures have. So the branch connector will initiate IPsec tunnels to either a third-party device, like a firewall at a customer's data center, or a third-party data center from a partner. I see that scenario quite often as well, or a legitimate, third-party service that requires that IPsec connectivity. And so what that allows us to do, or what allows a customer to do, is to deploy this zero trust framework, this is zero trust architecture across all of their sites, knowing that they still have that safety net of being able to instantiate a very specific routed path for the 10% or so is usually what I see of traffic that sometimes exists at a branch that still requires that traditional networking concept of, hey, I have to understand what is the source IP of this thing that's calling me, like a TACX Plus server, for example, right? Or again, VoIP being the poster child of those types of protocols. And so that will give us that capability. I'm pretty excited about this because, again, it will allow our customers to transition, right? Again, if it's greenfield, no problem. You just have to ensure that, you don't have those legacy protocols there, and you're deploying more updated and modern applications and infrastructure that are cloud-driven, cloud-managed. But the reality is, again, that's not true for the vast majority of scenarios. It's grayfield. It's stuff that's been around for ages now that need to be maintained still, right, until they eventually fall off the vine. And that should not prevent customers and organizations from continuing moving forward and improving their security posture just because they have 10% of traffic that doesn't play nice, right? So we're bringing that capability.
Yeah, when we're doing this in a secure fashion, right? Not simply extending the branch into the greater routed network across the WAN, right? So the branch is still distinct, but when it needs to communicate out to these applications, it's reachable. Right?
Yeah, and it will still be policy-based, by the way. We're not just going to say, okay, here you go, have a routed path, go ahead and figure out you can touch anything you want. No, we'll establish those IPsec tunnels, but all traffic will only be placed inside of those IPsec tunnels based on policy that the customer will specifically say, oh, you're trying to get to my TACX server? Okay, go via this traditional routed path as opposed to the zero trust path.
And then last but not the least, super excited to announce, I know we looked at the available appliances. One request we got a lot from customers is like, hey, I want to support 5G cellular, right? So we're excited to launch 2 new models that have cellular connectivity built in, the ZT400C and the ZT800C. And what are some of the use cases that customers can unlock with this?
Yeah, usually what I see is the desire to have that cellular connectivity as a secondary or tertiary link, WAN link. And certainly we could satisfy that today with some sort of dongle, but it's yet another thing to procure, yet another thing to manage, and so on and so forth. So embedding that into solution only makes sense, of course. It's also pretty standard for for traditional SD-WAN gateways. So we're no different in that regard. We will provide that WAN connectivity embedded based on the cellular radio within the appliance.
And this is also great for field locations, right? Like oil rigs, wind turbines out in the middle of nowhere.
Absolutely, for pop-up stores, things of that nature where, hey, I'm going to have this trailer at this construction site for the next 3 or 6 months or however long it is. I'm not going to run wires out there. I'm just going to use the cellular connectivity as the default WAN, and that's absolutely fair as well.
And then I know you're excited about this one.
Yeah. So like I mentioned earlier, we started on the smaller side of the spectrum from a branch size, right? Lots of demand, lots of interest in this type of architecture, which is very encouraging to see, of course. And so sooner than expected, we are releasing and working towards our 5 gig and 10 gig appliance for large campuses and even data centers, so that now folks don't have to leverage virtual appliances and scale them out laterally. They can work on larger throughput chunks. And even if they want to put them not physically in line, they can leverage these higher throughput appliances to scale laterally at data centers and large branches that have 2+ gigabits of throughput.
Thanks, Nuno. So this was a great, fantastic overview of what's available now, what customers can do today, and what's coming down the road that we're excited about. And I'd encourage everybody to take your first step today. Request an architecture workshop where we can sit down with you, understand how Zero Trust SD-WAN will fit in your environment, help you solve a lot of security challenges, and also help you reduce your infrastructure costs as well, right? And along with this, I'd also highly encourage you to watch the Breakout on Zero Trust device segmentation. It's a really great technology that can help you isolate and segment within your branches, campuses, and factories down to the device level and completely isolate the IT side of the house and the OT side of the house. And with that, thank you all for joining. It was great to have you. I hope you learned a lot, and we hope to hear from you.
Thank you all. Thank you, Amit.